All right, let's continue. I don't think I'll need half an hour for this, but let's see. And I think this is a topic that at least several of you are interested in how this is done and what the status of this is. So I'll talk a bit about how Spack can be used on top of EaSI to combine these both of these ecosystems and see how well that works. Now, there's a couple of disclaimers here. I'm not a Spack expert, but we have two Spack experts in the room. If I say something stupid, please interrupt me. Yeah, so talk to Massimiliano or Harman if you have difficult questions. I'll just point to them. Most of the work I'm presenting here was actually not done by me or by Alan, but by Loris, who used to work with Davide at CICAM, but he moved on to something else. But he did a very good job at documenting what he did and sharing it in a GitHub repository and so on. So that's been very useful as a sort of checkpoint of the proof of concept that he did. What I also want to mention, I'm a bit scared to do live demos here because I'll be using Spack. I'm not used to that. And the last time I played with Spack, early 2018, I found a big bug in Spack. So who knows what will happen?
That's already a statement. You didn't come since 2018.
No, I stopped trying after the last. Okay, so what we want to do here is install software with Spack on top of what EaSI already provides. So we want to try and convince Spack to reuse everything that EaSI has in terms of software installations as dependencies. So Spack doesn't need to reinstall things that EaSI already has. So dependencies for the software, compilers, everything that it can, glibc, it should reuse from EaSI and not install things. And also, it should not rely on the operating system for anything. So the glibc should be coming from the compat layer, not from somewhere else. The main mechanism, and Massimiliano already mentioned this, is the support for externals that Spack has, which is improving still, right? And I think we're actually relying on some of the recent developments here that were done.
Spack 1.1.
Yeah, in Spack 1.1, yeah. This is already in the documentation. Is 1.1 is already released, right? Yeah, okay.
1.2 is upcoming.
1.2 is coming soon, yeah. So yeah, we want to avoid that Spack reinstall stuff, at least the stuff that it doesn't need to reinstall. The proof of concept here was done by Loris. He wrote up a very detailed blog post on this, which looks like this. And it explains everything, like why are we doing this? What are the steps involved? He did a demo here that was recorded with ASCII Cinema as well, so you can actually see it in action. You can step through this. You can select text if you want to redo something yourself. So this is a very nice blog post to check later if you're interested or if this goes a bit too quick. And there's also a GitHub repository here that we moved under the EaSI organization. So it was under Loris's account originally. It got moved just today or yesterday. And it got the name Spood. Originally, it had EaSI Spack, but some people don't like that because Spack is not difficult, right, Massimiliano?
Exactly.
So we shouldn't imply that it's difficult. So Loris came up with a name Spood, which is like a spider. That's okay. It's a fancy name. It's quite okay. So you can check into all the code that's being used for this as well. But let me step you through this and see it in action. So the first step that we'll do is install Spack. And we have to be careful here because Loris had to make some small changes to Spack for this to work well. So we're going to use his fork of Spack and the EaSI branch that he has in his fork. So let me start by setting that up. In here, this is just an empty directory, so I'll start with cloning Spack because I typically don't have this thing installed for reasons. Spack is not installed in EaSI yet, but it could. People are having trouble with installing Spack, let me know and we can add it. But usually, yeah, this is how you typically use Spack. You clone it. Here I'm checking out the branch, going back, sourcing the script. So this is standard. And then Spack should be working. And you should be seeing a particular commit of a development version of Spack 1.2. So that's step one. Then step two is cloning the Spood repository, because that gives us a bunch of things to play with. So I'll just clone this, go in here. And then we have some script here. There's examples here, including we tried two approaches. First, in creating a Spack database, which was a bit more involved. But then after some discussions with Todd and Massimiliano, they suggested that we looked into the external support. So this is really, this packages.yaml is most of the magic here. That's how we expose things to Spack, what's available in Easy. And we can look into that a little bit as we go. Now, again, Loris did an amazing job here. Essentially, what you're interested in is this quick start script. Before we run that, we need to make sure we have Easy configured, which is already the case here. The proof of concept was done with the older version of Easy. If you try the newer version of Easy, it will probably not work, or at least you'll need to do some additional effort to get it to work. So we'll stick to the older version. I will run the quick start. So this is going to step-by-step do things. You can follow it in detail. I won't go through all the steps, but it essentially configures Spack to be aware of that packages.yaml, to be aware of what Easy already provides. It's then doing a bootstrap, so that's the Klingo thing. It shows the output of some Spack external find commands, and it's really going quickly. So I can scroll back a bit. So it's doing a Spack external find to show what it knows about. So all of these things are essentially coming from, I think this is the compatibility layer. Yeah, so coming from compat. And then here, this is configured external. So here it's showing you all these things are coming from the compat layer. And there's also, yeah, it also gives us stuff coming from the software layer. So it's found in OpenBlast, a particular version built with a particular GCC, and it knows the installation prefix of that. And that's true for all the things we told it about, which is only what we need for our demo, which is going to be installing, again, Quantum Espresso. So it's good that we are aligned. Yes?
Is this a fixed list of, for example, package name? So
yes, right now it is. For the proof of concept, it's actually this file here, this packages.yaml, which is a manually created file that knows about some things that Easy provides. The long-term goal, and I'll get to that at the end, is actually to auto-generate this file. So essentially for everything that Easy has, we create a file that knows everything, and then Spack can pick it up and knows about everything that it should be. But for now, this is largely manually created. And then here it actually goes and does, this is just looking at the spec for Quantum Espresso. So now it's definitely already talking to Easy, doing lots of queries into Easy, figuring out what things are about, and eventually it should start the installation.
There may be one important thing to mention is just previously, one of the steps in the script is to match the targets, right? So to match the architecture that, so there's an architecture that Easy sees,
yeah.
And then there's an architecture that,
yeah, there's some kind of mapping here.
Here it's just there.
Where is it?
Just there, just updating packages that have for your
here, yeah.
So that's the architecture that Easy sees, but then Spack doesn't see exactly the same thing.
Yeah. So there's indeed some mapping efforts being done here in terms of what CPU Spack detects and what Easy detects. Also in terms of naming of software, the names are not perfectly aligned. I mean, there's two different ecosystems. So what Easy thinks is OpenBlast, I think Easy uses capital letters for O and Blast in OpenBlast. In Spack, everything is lowercase, so we have to map things to each other. And that's where it gets interesting to auto-generate this packages.yaml. Now let's see how it's doing here. I already completed, okay. So
it's the fastest demo ever.
well, that's what Easy gives you, makes things fast. Yeah. So what we did here is essentially a Spack install. Where is it? This is the output of Spack here. So we did the Spack install Quantum Espresso with, this is a variant, MPI variant enabled? Without MPI, yeah, okay. And then it tells us, okay, this is all the things that are already found, so I don't need to install these things. And it essentially needs to install three things: a compiler wrapper, that's something Spack needs to build other things. It generates a runtime wrapper as well for the GCC that it finds.
Okay. It's basically the runtime libraries so that you can avoid pulling in the compiler if you just take the binary.
Okay, but there's not really installing anything, right? This is just like...
It's installing.
Okay.
It's a copy of the runtime.
It's copying it, yeah, okay. And then Quantum Espresso itself, which is where the actual installation. So this installs in like 2 minutes. And then to verify that, we're doing again an LDD like I did on GrowMax. essentially showing that everything is coming from either EasyBuild, so F50W, all these things. Here, this is coming from the runtime, so that's that copy that Spack has made from the GCC provided by Easy into its own, what do you call this? Store? Yeah. libm is coming from the compat layer, OpenBlast is coming from Easy, and so on. So you can essentially tell everything is coming from Easy except for the stuff that Spack installed itself. The demo ends here. The blog post goes a little bit further. If I can make this a bit bigger. So here it actually also shows that the binary that you get from Quantum Espresso is also actually running. You do this Spack load of Quantum Espressos that uses what was built, and then it runs the binary and it shows that Quantum Espresso is indeed also running correctly. Again, just a proof of concept. This is without MPI, this is single node, so, but at least conceptually this concept can work. All right, so this is just a screenshot of what was there. The same thing can be done in a CI environment, so a bit like Alan showed in GitHub Actions. It's very easy to use Easy in CI. We have a special action for it, so you just use the action in your workflow, and Easy appears there. You can just start using it. Same thing goes for GitLab runners. It can also easily be activated in a GitLab runner. And that means we can also easily use Spack inside of GitHub Actions on top of Easy. So the Spood repository actually has a workflow that shows this. All right, so let me go back to the root here and just show you what that looks like. So we do a couple of steps. We check out the repository. We use the Easy GitHub action, which will make Easy available in this environment with the old version of Easy. And then we essentially do what I did, or what Loris' script is doing. We clone Spack, we apply the patch, so that's similar to cloning or checking out the Easy branch of Loris' fork of Spack. We set up Spack, and then we run the quick start like I did manually as well. And just to show you that this actually works, we can check at the output here in GitHub Actions, and you can see the whole thing in action. If I can, why can I not open these guys? Ah, okay. Let me jump to a different browser. So here we can see the output that this generates, and you can see it just applying the patch, and then the same output that you saw. So whether we're doing this in GitHub Actions or in a Linux VM or whatever, it essentially just works. And that's, of course, a useful thing if you want to make sure your the installation of your software is working with Spack and keeps working as you make changes to it. This is one way of doing it. You're getting all the dependencies from Easy, and you're essentially just doing a Spack install of your software on top of that, and that all works. Of course, there's probably more work to do here to make sure you're using the latest version, the latest developed branch of Spack to make sure that keeps working and so on. There's a whole lot of trickery you can do here. But it should make things easier, and at least with this, you're not relying on a build cache. You don't need to maintain a Spack build cache. You can just reuse what Easy provides. And it doesn't matter whether you're using Ubuntu or another operating system. It works both for x86 and ARM, so it's doing both here. So this may be something you want to look into. I can show this actually, yeah. And well, let me get to the next steps. That's just the last slide. So this is essentially what the workflow looks like. I showed this. So this was a proof of concept. It's like, can we do this? Is there a reasonable way to do this? And talking to the Spack developers, yes, externals are a good way to do this. This is actually sort of what the external feature in Spack was implemented for, at least one of the use cases. Right now, you need to use a patched version of Spack. Loris has opened a pull request, which neither of you have looked at, so you should get to that. Okay, maybe you did. I'm not sure what's in the pull request is sufficient, so I haven't looked into that part. The pull request does some things, but maybe not everything that is done in the branch. And here we can actually look at the diff. So this is what Loris did. I don't think this part matters. That's probably his personal setup. And in here, he's playing in the support for externals in Spack. I'm making some relatively small changes to this. Like I don't know the inside of Spack at all. Some of it is just debugging stuff. And it's possible what's in the pull request is actually already enough to make things work. It's also moving some code around, I think, making it a static method. So all in all, it's not very shocking. I'm not sure if this part is actually really necessary. So here he's making Spack aware of essentially the easy compat layer, so the Gentoo prefix environment that we have. I'm not sure why he needed to do that, so that part I'm not really sure about. But the actual changes are quite limited. And one of the next steps would be to try and make sure we can just use normal Spack for this to happen. So whatever enhancements or fixes, or I don't know what Loris had to do, getting that upstream into Spack would be a very nice first step. There's more steps though. We definitely need to do more testing. I think we only really tested this with Quantum Espresso. Not sure if Loris tried other things. He attended to, but I'm not sure he ever got to it. We've just done a very minimal functional test of Quantum Espresso. We haven't looked at performance or anything like this. Maybe there's important aspects there to take into account. We definitely want to auto-generate that YAML file. Like we're not going to do this manually for everything we add to Easy. That would be totally insane. So we need scripting that regenerates that packages.yaml for everything we have. Ideally also some kind of way of detecting variants and mentioning those in the packages.yaml. That's going to be pretty tricky. So maybe we need extra code for some packages that detects which variants Easy has and then translate that to Spack. That's going to be interesting. Eventually, if we do have a good way of auto-generating it, we'll just include the packages.yaml in Easy itself. Because it's just an extra file that we can generate again and again. It's not quite scary. And maybe this should be paired with an easy extend module. So you can do easy extend /Spack and then do Spack install and everything happens for you. That may be possible. We'll need to figure out a way to do the name mapping as well between software names because things don't have the same name. A lot of this can be automated or with heuristics probably detected. But there's going to be like the 1% is going to be the painful part here that we probably need to do manual mapping. We'll see how that goes. And yeah, easy extend is probably a good idea for Spack as well, next to the EasyBuild one we have. So as a proof of concept, this was pretty interesting. It actually took Loris quite a bit of time to figure all of this out. But I think with what we see now is we're confident that we can actually make this as a properly supported use case and make it as painless as we possibly can. So any questions on this? If people are interested in playing with this, this could be an interesting one. If you like playing with Spack on top of Easy in the next day and a half, I mean, all the people in the room are here, Spack developers and the Easy experts, to maybe make some next steps or help explore what can happen.
Not only of the pie,
You can define the external like for all these packages and then look at it.
One question I would have is basically, are the dependencies of the detected packages already in there? I mean, you showed that this works in modern Spark.
this works, and now it needs to be manually implemented, and I think Loris did some.
But he did it for the ones where it matters. Yeah. But again, this would have to be part of the auto generation. So there's variants, dependencies, just flat list of everything that's available. Software layer and compat layer are different enough that you need a different mechanism to expose those, or at least different scripting.
Some packages basically including multiple packages.
Yeah,
yes,
exactly.
Yeah.
That would be also the difficult part.
Yeah.
Like if they split a package and we didn't, or maybe that one could be easy, but if they have
merge things, yeah. We definitely do this. Like X11, for example, is a bunch of things installed together.
Yeah, even the other example, we should go. So we should go the OpenP version and
in the same prefix. Yeah. So yeah, this is probably never going to be perfect, but we can make it as painless as possible.
I think the overlaying prefixes, if you just install different library names, it wouldn't be wrong. Just basically.
Yeah, that's what we do, of course. If multiple variants are installed in the same prefix, it's because they have different library names.
So I think like the biggest use case for this would be saving time, right? So things that are expensive to compile, like LLVM, something like that, whether it's time, and you don't have to do that.
Yeah, but also trust into that packages are already performance tested by somebody else.
Yeah. Not only performance, but also functionally that they actually work. Like what Massimiliano briefly mentioned is sometimes if you do a Spack install, you're the first person to install that combination or configuration, and then if you don't test it, God knows how well it works. Everything in EasyBuild has been not extensively tested, but at least a bunch of people have looked at it, and usually we rerun the test suites for everything we install as well. So.
But people say, I think sometimes EasyBuild
yeah, so that was the first thing we tried. This is in here as well. This is this upstream DB thing, I think. So Loris did some scripting here, and we have meeting notes that we can share as well. They're somewhere in the HackMD document. That was the first attempt that Loris did to write a Python script to generate a Spack database for stuff in Easy. That was also painful, and there were some things like, okay, in that case, there were some use cases or some special cases that were difficult to handle. And then after discussing it with Todd and Massimiliano, they just told us, use the externals instead, because that's still being developed, still being improved, and that's a more promising path forward.
One question was the difference between modern Spack.
So in 3.1.0, I think Spack was kind of mapping an external entry to multiple things, which is weird. Because there is a single installation. And now it basically allows you in the packages.yaml to have a number specification, and it assumes that all the rest are the default values. That's theoretically we have. It's very simple. If something doesn't match and you need it in a specific way, you should keep a better specification or a better detection method in the package.
We have a question from the online participant. Is the 1.x version of Spack generally deployed on computer centers? Apparently, CINECA is still running 0.22, but I can answer that. Okay. But I can answer on that because I know that CINECA is now installing the new software stack with Spack 1.1. So okay. It's correct. Is it correct? Yes.
And I think typically people just self-install their Spack if they want to use it, right?
Yes.
Yeah. What do you mean with developers? Software developers or Spack developers?
I mean, usually I would say I think software developers probably typically use latest or don't care too much about the version. But sysadmins who provide for users, they are more tied to specific releases.
Yeah. Okay. Yes, okay. We'll share the slides in the shared drive, so if you want to take a look at this, you'll have all the details. Yeah, and I hope we can find some time with Todd and Harman in the next hours and tomorrow maybe to figure out concrete steps and maybe review the patch that Loris had to do to see if that's possible to upstream. That would be interesting.